Hello everyone, welcome back to another remote sensing lecture video. And in this lecture video I want to begin our module off talking about this idea of accuracy assessment. Right, accuracy assessment. And I want to begin with this because we have to sort of contextualize what we've done in the previous modules where we were talking about classification with how do we know whether or not this algorithm has actually done a good job. Right? And if you think back to unsupervised classification and the supervised classification labs that we've done, right, up to this point, we basically just looked at the image and then looked at the results and said, hey, that seems kind of okay, or it seems like there's some sort of an error there. And so what we were doing was, in effect, a form of accuracy assessment. But what we were doing was called qualitative accuracy assessment. Right, where the user visually interprets the results. All right, and now, so you've got to think just from doing this, right? That it worked okay, right? You got a good sense of, the image, but it wasn't really rigorous, right? We didn't use numbers or anything like that. But there are a couple of reasons why we would want to do this. One, right? This is great for finding non-systematic errors. Right, non-systematic errors might be referred to as unique errors. Right, and let's say, for example, a good example of a unique error might be, again, talking about water and the idea of a swimming pool. Right, and so depending on the classification scheme and the way that we set up our training data, right, maybe we wanted a swimming pool to be included or excluded from water, right? Qualitative accuracy assessment, where you're visually examining the image, would be a great way for you to figure out whether or not that particular area went in the class that you wanted it to. Right? It's a great way of finding these sort of specific or unique errors. But it's not, again, it's not rigorous, right? We're not using numbers. So what I want to do in this module is I want to go through the idea of quantitative accuracy assessment. Right, quantitative accuracy assessment. And we're going to spend an entire video just sort of setting up more of what this looks like. But basically, a quantitative accuracy assessment uses testing data. Why can I not get that D to look right? Testing data, or sometimes you'll see it called validation data. And an error matrix. To mathematically assess model accuracy. Right. And so we're going to spend an entire video talking about error matrices. But what I want to do right now is just get this idea of testing data and clarify what that means. So testing data is essentially the same thing as training data, right? It's pixels that we tell the computer, hey, I know what this pixel is supposed to be. But testing data is data that we didn't use to create the model, right? This is an additional set of locations that we know about, but the computer hasn't seen, okay? So it's the same thing as training data, but the model didn't know it existed. Let's actually write that down, right? Right, that's really terrible. Right, but the model didn't know it existed. And so we're going to go through in the next video talking about this idea of an error matrix and testing data. So hopefully this makes sense, this idea of qualitative accuracy assessment, which we're kind of familiar with, just being the fact that you as the user are just looking at the image and the classification and saying, that seems accurate, that doesn't. There's this specific area that I know is having a problem. Versus quantitative, which is what we're going to talk about in this module, where we're actually going to use this new set of data, right, the model did not have access to, and this idea of an error matrix to mathematically assess model accuracy. So hopefully this makes sense, and as always, please reach out. Thank you.